Hello, and welcome to Vitruvius. Our Vitruvius engineer, Brian DeMeza, will be giving you an in-depth walkthrough with some helpful information to get you started.
This walkthrough will cover all the steps used for any of the Vitruvius beam modules, and I will show you some of the small differences between each of those. Over here in the design module dropdown over by your username, here we have the floor beam, the floor joist, a roof beam, and the roof rafter. Let's open up the floor beam and start our design process. The floor beam has opened up and loaded from a new floor beam template, and automatically that comes with a load on here, so we can see that this load is highlighting. Down here in the load cards, we can see that it's a snow load acting in the y-axis with the magnitudes of 40 pounds over the span of 10 feet, so 40 PLF. I'm going to go ahead and just delete that so we can start fresh. So first things first, we have our properties panel on the left side, the loading diagram in the center, our shear moment diagrams on the right after calculations, and then we have spans, loads, and adequacy toolbar down here in the bottom. We can edit the properties in any sort of order. Let's start from the top and work our way through some of the options. So the first button here on the left says lrfd, and this is where we can toggle between lrfd design or ASD design. So we can click that and switch the design methods. And we can also, for wood, we have the wet and dry factor. So we can click that and apply the wet factor, or we can go back to dry. Each design module will have a different set of properties associated with it, but for the floor beam, roof rafter, and floor joist, only the size section will have differences. We can hit the drop down to zip it up if we want to have a more clean view, or we can leave them all down and open to see what all of our properties are. In the material section, this is where we will select our template, material, species, and grade, as well as some other checkboxes for code requirements. So first on the top is the template. The template allows us to save our properties and do quick and easy designs where we have everything already ready to go. We have the loads we want on it. We can save all of that stuff into a template. So for the materials down here for floor beam, we have solid sawn, glulam, structural composite lumber, I-joist, and steel. We can use the include self-weight, and we can uncheck it if we do not want to include the self-weight in the analysis. We can check for unbalanced loads, and we can also check for the concentrated live load. Then we can go down to size. We have the number of laminations. We can select one, or we can type in our own here. Then we have the width and depth of the beam, which we can select since we're using dimensional lumber. The next section is options. We can use these to adjust our beam, so we can make this a flitch beam. And then when we click that, the flitch beam option will appear where we can select the number of steel plates in the flitch beam, as well as the desired thickness of the plates. We can also check if the beam is round, so if it's a post, and you see the size changes. So now we're just selecting the diameter of the beam. We can also apply the flat use factor here. Next we have the factors section. The factors are included for all of the wood calculations. Here we have the temperature factor, where we can select the temperature range the beam will be placed in. We can apply the repetitive use factor, we can apply the incising factor, and we can also include the creep factor here. For the deflections, we can select the live load deflection or total load deflection limits, which is our L over 180, 360, 240, whatever the code prescribes, we can change that here. And then finally, elevation. Elevation sets the left and right elevation, so if the beam is angled, we can change that. Now if we select glulams for the material, we can see that the species changed, the grade changed, and an additional checkbox appeared, as well as some of the factors were removed from the factor section. We have a curved glulam option, and when we click that, we can select the radius of the curve. The species have changed to the stress classes and also the different grades. And we see that we lost a couple factors since glulams are designed without those factors. The deflections stay the same and the elevation stays the same as well. We can switch to structural composite lumber. Now in species, we have some of the common manufacturers of structural composite lumber here. For each manufacturer, we'll have a grade so we can select the product we want. And then in size, we now have widths and depths according to the products. For options, we have the flitch beam and the flat use. The factors stay the same as the glulams. Again, deflections and elevation do not change. We can choose an I-joist for the material. In the species, we have our common manufacturers, and then we have the grades listed as well. The size doesn't have a width anymore, but it does have a depth that we can select based on the product and grade. And then factors, we only have the creep factor. Now let's go to steel. Here's where things get interesting. We now have an additional grade option where we can select the steel grade. The species provides the shape of the steel. The next one down, we can select the size of the steel beam. And then below that, we can select the grade of the steel. The same checkboxes apply, the self-weight, the unbalanced loads, and the concentrated live load. Because we're using a steel beam, we've already selected the size up here, and we don't have any factors that apply like during wood design. So we have the deflection limits, these stay the same, and then elevation stays the same as well. And that's really the main differences here between all the different materials. Now let's take a quick look at some of the differences between the floor joist, roof beam, and roof rafter compared to the floor beam. When a floor joist design module is selected, the only thing different here will be in the size section of the properties. In this, we now have an additional on-center spacing that we can select or input something in ourselves. The variation on the roof beam is shown in the size section, and now we have a roof pitch, which we can update to match our design conditions. For the roof rafter variation, the size has the roof pitch as well as an on-center spacing that is selectable, or we can input a value here. Okay, so now let's go back to the solid sawn beam. So let's move to the middle of the screen. Here we have our floor beam loaded, and this is a tab document, so we could have additional tabs here of beams or columns or whatever we're designing here. This first toolbar we like to call the top toolbar. This has our calculate button, auto size, save, as well as the print preview after calculations have been run. We have the location name input box, so we can adjust this based on whatever we want to call it. And we have our close button here, which exits the tab, and we can choose to save from there. The reactions are shown at the end of the spans. So we can actually click on these reactions if we want to change them. We can set them to whatever we'd like them to be. The deflection and rotation boundary conditions are automatically set based on the icon we choose. So if we want this to be fixed, everything goes to fixed. Let's go back to pinned for our simply supported beam. We can also adjust the bearing length or apply the Hankinson's formula for wood calculations. Over here I mentioned the add and delete spans, so we can easily just add a span. So now we have an additional span over here of 5 feet, and we have the total length of 15 feet. Let's click this and make this a cantilever, so we can apply the free reaction to that. So now we have a 15-foot beam with a 5-foot cantilever. So now we could run the calculations with just the self-weight, or we could add some loads to this beam. So let's go through the add loads buttons here. We can add a uniform distributed load. We can add a trapezoidal distributed load. We could add a point load. We could add an axial load. We could also add a moment at any point, and we can add a linked load. Let's add a uniform load here. We can say let's add a dead load. We want this in our y-axis, which is down. So here's our dead load. If we wanted to edit it, we could just click it and edit in any way we'd like, or we could delete the load. We can do the same thing down here where the load cards appear, and these will populate as we add loads. So now I'm going to speed this up and put a bunch of loads on this so we can see the capabilities of the loading diagram. Now that we've got this thing all loaded up, so we can click any of these, edit them, adjust them. We could go down into the load tabs, and as we hover over each one, they will highlight, and we can edit those from there. As I mentioned before, we're viewing all loads, so we can change that to just see the seismic load, and we have that moment there. We could change to see only the snow load on the cantilever. We could just choose the roof live load, which we'll have to change our axis to see. Or we could use the live load or dead load. Either way, we go back to all, and we have our beam all loaded up here. So we're back to just the one uniform dead load here. I mentioned on the right that we have our calculators, and here we can add another load by using the tributary width calculator. So let's add a uniform distributed live load on the y-axis based on the tributary width. So the area load, let's say, is 50 PSF. And then we have side 1 and side 2. So let's say that that's 3 feet and 3 feet here. And you notice in the bottom magnitude, the load applied is always changing based on the numbers you put in here. So you don't have to do anything except put in your distances and your loading conditions. We can apply this over the entire length of the beam here and add it, and you see the load has now been added. From here, we could hit calculate and calculate the beam as is, or we could hit auto size or save it and calculate another time. Let's go ahead and hit calculate. So once we hit calculate, we have our adequacy cards appear in the bottom panel. So here we are all good on everything because everything is green. If any of these were red, we would know we were not passing in that area. And we have the controlling load case here, the magnitude, the strength, and the location for every mode. On the right, we have our shear moment diagrams as well as the deflection diagram. And up here, we have the controlling case, but we could also change the axis. Now, if we want to get a report of our calculations, we can come up here and we see that the print preview button has now appeared because our calculation has run. We can click that. And we've got all of our project properties and location and the code. And then as we scroll down, we can see more of the beam properties, the type, the strength properties of the beam, their adjusted values, the factors used, some more of the beam data, and then a pass-fail for each mode, the magnitude and strength, all the things shown in the adequacy cards there, as well as the reactions and the loads. This is the same format for all the design modules. There'll be little differences depending on which design module it is. Alright, so let's close this down, and let me just run through a really quick calculation and show you how easy the auto size function is to use, and how quickly, once you get used to this whole system, how quickly designs work. So I close that. Let's open up another floor beam here. This floor beam loaded in the template. So we have a 40-pound snow load on here. And we can just go ahead, and we don't have to do anything since it already has a load. We could change the load if we wanted to, but I can show you real quickly. We have a load and a span, and we can just hit select all, make sure this is all good. We're happy with that. Hit the auto size. Then we can just click this one. It's our best option. 32% adequacy, deflection, and it's our lightest. So then that's it. We're all good, and our adequacies, our shear moment diagrams are looking good, and we can click save, or we can hit the print preview here, and we've got it all there. So that was super quick and easy, and this is just one of the big advantages to using our software, is a really speedy design. Check our other walkthroughs for more information on the other design modules.
We hope this information was useful to you. The Vitruvius team is standing by to assist you directly via email, phone, or even a remote session. Thank you. We appreciate you being a part of the Vitruvius project.